we are trying to solve here is use generalized compressibility chart to estimate Z, which is the compressibility factor, right? We are estimating here Z. We're estimating Z for nitrogen, right? For nitrogen. Species is nitrogen, and which is at 40 degrees Celsius and 40 MPa, which is 400 no why I'm not able to. (40 MPa), right? Which is 400 bar, roughly. Okay, now atmospheres, So, how do we do this? Basically, N2, we have to get the TC and PC. Can anyone tell me where those data are? If you go to your tables at the back, right, you should see PC and TC, right? Okay, Appendix B, B1 table will give you for nitrogen. Let's see here, nitrogen. TC is 126.2. Okay. And PC is 33.6, 33.5 bar, or atmospheres, okay? Are you with me? Do you have the books? You don't have the books, right? He has the book on a PDF there. All right. So now, for compressibility factors, compressibility chart, we need reduced temperature and reduced pressure. So basically the actual temperature, so P R equal to P divided by PC, right? Oops, PC. So what is P here? 400 atmospheres. All right. Divided by, actually, 33.5 atmospheres. Really, 40 megapascals is not equal to 40 atmospheres. It has to be divided by 1.013. Megapascals equal to 1 atmosphere. So this should be actually, this should be 400 MPa. That's what is given to us, right? 40 MPa, yes, exactly, 40 MPa. And there are 10 atmospheres in 1.03 megapascals. So that's what it is. 10 atmospheres equal to 1.01. So now megapascals get cancelled, and you get your atmospheres gets cancelled. So you get your value. So what will that be? 400 divided by 1.013 divided by, you're getting what? 11.78. Wonderful. It's 33.5, yes. Yes. 11 point? Okay, 78. So this is your PR, right? Now let's go and look at TR too. T over TC. What is the temperature here? 126.2 K divided by the TC. TC is given, oops, sorry, I'm sorry, here. That's not the actual temperature. The actual temperature is 40 degrees Celsius. Okay, 40 degrees Celsius. 40 degrees Celsius plus 273, that'll be K, divided by TC is 126.2 K, right? So now what will that be?
2.48.
How much is that?
2.48.
2.48. Okay, I'm taking for granted 2.48. Okay, now where do we get our Z or charts? There are some charts that are given to us in the textbook. So if we go through that, it's 5th chapter, and we should have compressibility charts. There you go. Compressibility charts at high pressure, medium pressures. There are two, 5.43, 5.4, right? 5.44. Let's go to here. Reduced pressure for us is about what? If I look at here, 11.78. So we should use the high pressure one. If you go through the textbook, there are two charts here. If you look at this goes on the x-axis here up to 10 bar, and this goes from 0 to 40 reduced pressure, not bar, reduced pressure. So we are at 11.2. So which means we have to use this chart. Are you guys following? If you have it, you can see. If you don't have it, we will just use this. Now, so at 11.8, 11.28, 11.78, which is 12. So let's say 10, 11, 12, roughly, and then if we go on the VR or TR here, the dark lines there, TR is equal to what here for us? 2.48. Okay, 2.48. There is a line for 2.5, and if I go to 11. That's coming out to be roughly about 1.2, 1.2 and 1.4 in between. So that is somewhere around 1.2, I would say, very close to 1.2. So our value would be, from the compressibility chart on page 211, which is table 544, for reduced pressure of 11.78 and reduced temperature of 2.48 on the solid line, we get about Z equal to 1.2. Okay? That's how we get it. Once we get Z, it's very simple. Now you can use the same equation that we have been using, PV equal to nRT, but add Z there. PV equal to Z nRT. Z will be 1.2. If we want to calculate the volume or whatever we need to calculate, we can use the same equation here. All right? Are you guys with me?